Good afternoon, students. Today we are going to discuss acids. How do you feel when you drink an alright fruit? It's hard. Or when your food is fermented, or you left your food on warm for some time and you now taste it, what happens? It's called sour. What is sour? Presence of acid. So you can say acid is a substance. There are so many theories that give the definition of acid. We have theories of acid. So we can define acid in so many ways as we are given by different scientists. If I ask you what an acid is, majority of you will say an acid is a substance that produces hydrogen ion when dissolved in aqueous solution. That definition was given by the scientists. And who can tell me the name of the scientist that gave that definition? Arrhenius. So that means we have Arrhenius' definition of acid. So we have Arrhenius, which defines acid as a substance which produce hydrogen ion when dissolved in solution or in aqueous solution. So that means a substance that produces hydrogen ion when dissolved in aqueous solution is referred to as an acid. That definition was given by Arrhenius. So because Arrhenius thought that every substance that contains hydrogen or all acid must contain what presence of hydrogen. Another, we can also define acid in terms of procellurate. Can everybody tell us how procellurate define acid? Anybody? An acid is a substance which donates proton. A substance that donates proton is referred to as an acid. That definition is given by procellurate. So, acid are substances that donate proton. You know, proton is hydrogen ion without electron at the outermost shell. So it is also conformed with that of the definition given by the Arrhenius. A substance that produces hydrogen ion when dissolved in aqueous solution was given as an acid by Arrhenius. But a substance that donates proton is referred to as an acid. That one is given by procellurate. That's okay. That's another theory. Then the third person that gave the definition of acid, we have Lewis' definition. Lewis theory. Lewis defined an acid as electron pair acceptor. So acids are electron pair acceptors. All this theory, you must know them as they give the definition of an acid. An acid is a substance which, when dissolved in aqueous solution, produces hydrogen ion. Arrhenius, a substance that donates protons, is also referred to as an acid, and that is given by procellurate. Why Lewis defined an acid as electron pair acceptor. Are we together? Now let's look at this. If I write NH3 plus H plus to give NH4. You have ammonia reacting with hydrogen ion to give ammonium ion. Let's say we have ammonium ion. Which of these substances here is an acid? Which of these substances? You know, we have ammonia, we have hydrogen ion. According to Lewis' definition, which one of these substances is an acid? Yes? Hydrogen ion. You see that it is the one. When we write ammonia, there will be lone pair of electron in an ammonia. And this ion here has no electron at all. What happened? It will accept the electron from the lone pair of electron we have on nitrogen. So it means this one will serve as an acid. Is that okay? So all this theory now you must know how they give the definition of an acid. Are we together? Now, let us look at the strength of acid. Strength of acid. When you talk of the strength of an acid could be a weak acid or a strong acid. That depends on how the acid ionizes in water. If an acid ionizes completely in water, the acid is referred to as a strong acid. But when it partially ionizes in water, it is referred to as weak acid. So we can see, based on the strength of an acid, we have strong acid, we have what? Weak acid. So strong acid ionizes completely in water, while weak acid partially ionizes in water. So it depends on how the acid ionizes in water. That is when we are going to know the strength of the acid. Either it is weak or it is strong. Are we together? That means when you want to classify an acid can be classified either as a weak acid or a strong acid. That is based on its ionization in water. We have concentrated acid and diluted acid. Concentrated acid and diluted acid. When do we say acid is concentrated? And when do we say the acid is dilute? Can anybody try what a dilute acid? What a dilute acid is and what a concentrated acid is? Anybody? Anybody? Do you have anybody that want to try? Now, based on the amount or quantity of acid and water present, the acid could be dilute or concentrated. A concentrated acid is an acid that has large amount of acid in a few amount of water. But when you have large amount of water in a few amount of acid, the acid is said to be what? Dilute acid. So it means you want to find the ratio or the volume of acid compared with that of water. When we have large volume of water and few amount of acid, you can see we have a dilute acid. But when you have a large amount of acid with few amount of water, the acid is said to be what? Concentrated acid. So you can say concentrated acid has what? Large amount of acid in a few amount of water. But when you talk of a dilute acid, we are talking about the large amount of water and few amount of acid. Remember, when you are comparing the ionization of the acid, it will be strong or weak. When you are comparing the amount of water and the acid, it could be concentrated acid or diluted acid. Are we together? From what I've explained, can anybody tell me the difference between a strong acid and a concentrated acid? What's the difference between a strong acid and a concentrated acid? Yeah.
A strong acid, as I said, it ionizes completely. A concentrated acid may not be a strong acid. It's anionic acid. Even in concentrated forms, it does not completely dissociate in water. While a strong acid, whether dilute or concentrated form, it still ionizes completely.
You try, but that is not exactly what I want you to tell me. Strong acid is one that ionizes completely in water. Then what will be a concentrated acid? Who wants to try that? John. Paul. Concentrated acid. You have missed everything together. Yes?
It contains large amounts of acid in it.
What?
Amounts concentrated.
Now, if you are asked the exam to distinguish between strong acid and concentrated acid, what will you say?
Okay. Strong acid is the acid that ionizes completely in water.
Yes.
While concentrated acid is the acid that contains large. No, it may ionize completely in water.
It's amazing. Strong acid ionizes completely in water, whereas a concentrated is one that has a large amount of acid in a few amount of water. Both has to do with water. When you add acid to water and it ionizes completely, the acid is referred to as a strong acid. But when you have, let's say we have 100 centimeter cube of stock solution of acid dissolved in, let's say, 10 centimeter cube water, this acid could be referred to as what? Concentrated acid, because you have large amount of acid in what? In few amount of water. Are we together? But when you now have large amount of water, then you have few amount of acid. All the solution I gave you for the practical is referred to as what? Dilute acid. Because there at least I use 4 centimeter cube of the stock solution of acid, then dissolve in 2000 centimeter cube of water. Compare the ratio of the stock solution with this one. So this one can be referred to as what? Dilute acid. Are we together? Then we also have a mineral acid, then we have organic acid. So we can have organic acid, then we have mineral acid. When you say organic acid, most organic acid are from the natural sources. Those acids that are from natural sources are referred to as organic acid. But the mineral acid are the synthetic what? Acid. So most of these mineral acids are synthesized. We have acids like HCl, HNO3, H2SO4. All these ones are referred to as the mineral acids. Are we together? Majority of this organic acid, they have their sources. For example, let's look at most of this organic acid and their sources. So let's look at most of these one. We have organic acid. Let's say we have the acid, we have the source. We're going to do it together. I want you to mention one organic acid and the source of such acid. Yes?
Amino acid.
We have amino acid. Amino acid. Where do you get amino acid from?
Protein.
From proteins. Yes? Yes? Lactic acid. Yes? We have lactic acid. Where do you get lactic acid from? That is sour milk. It's not all milk. It's only when you have the milk that is that contains the lactic acid. Yes? Fatty acid. So we have fatty acid. Where do you get fatty acid from? From fat. So ascorbic acid. Here we have ascorbic acid. Where do you get ascorbic acid from? From orange. Yeah. From orange. Any other one? Yes, ethanoic acid. Where do you get ethanoic from? Metanoic acid from where? So we have metanoic acid. Metanoic acid from ants. Stink. So when ants stink or bite or bite you or sting. So what it injects that pains you is what? That metanoic acid. Now we look there. Citric acid. We have from citric acid from where? We have citric acid from lime or lemon. All these acids that we have gotten here, they are from that. Look at this fat oil. Are you the one that made the fat oil? The majority of them they are from natural sources. So and they are referred to as what? Organic acid. But most of all those ones that we use at home, they are synthesized. And they are referred to as what? Mineral acid. I'll give you the samples you have there. Now, when we mention the definition of acid, we know the three theories that give definition of acid. Most times frequently when you are asked questions, most of you are familiar with the definition of ions. And these are acid dissolvers, which when dissolved in water produces hydrogen ion as a positive ion. There are other theories. Apart from, look at this. What would have told that this was here? Where we have an acid here in this liquid. This one did not produce hydrogen ion. But what is that? For hydrogen here to combine with nitrogen here, there is a low pair of electron here of nitrogen. So one that combine with the hydrogen here before you can have ammonium ion. So make sure you know all these theory. Arrhenius theory of acid, Brusselloid theory of acid, then Lewis theory of acid. And when we want to look at the classification of an acid could be a strong acid or weak acid. An acid could be concentrated acid or dilute acid. Then we have organic acid, we have what? Dilute acid. Are we together? Now let's also look at basicity of acid. Basicity of So when we say basicity of an acid, when you are given one molecule of an acid, how many hydrogen ion is replaceable in that molecule? That number of hydrogen that is replaceable is referred to as the basicity of the acid. So we can say a basicity is the number of replaceable hydrogen ion in one molecule of an acid. So let us look at this acid. This is an example. HCl. How many hydrogen ion here is, or atom here is replaceable from this? That is one. That means you can say the acid. Let's have the acid. Let's have the basicity. The basicity here is what? Is 1. Therefore, we can say this acid is a monobasic acid. Why do you say it's a monobasic acid? Because it's our one replaceable hydrogen atom. I have a CH3COOH. What is the basis of this acid? It is only one. It is only the terminal hydrogen here that can be replaced. Though there are 4 hydrogen atoms in this molecule, but this molecule it can only have one of its hydrogen replaced, which is the terminal hydrogen. So it means the basis of this acid is also 1. Then we can say this acid, butanoic acid, is also a monobasic acid. Let's say we have HNO3 is also having a basicity of 1. Let's look at H2SO4. In H2SO4, how many hydrogen atoms are replaceable here? 2. So the basicity of this one is also 2. Or you can say H2SO4 is a dibasic acid. We have H2C2O4. This is oxalic acid, or you call it ethane dioic acid. What is its basicity? What is the basicity of ethane dioic acid? 2. So this also has a basicity of 2. Or you can also say it is a dibasic. So we have, let's use H3PO4. What's the basis of this acid? Therefore, H3PO4 is a tribasic acid. So if we are talking of the number of hydrogen atom that is replaceable in a molecule of an acid, we are referring to as the basicity of that. Now, who can explain the term? The basicity, H2SO4 is a dibasic acid. H2SO4 is a dibasic acid. What does it mean? What does it mean to say H2SO4 is a dibasic acid? What does it mean to say H2SO4 is a dibasic acid? Okay.
It means that it has 2 replaceable hydrogen.
What?
It has 2 replaceable hydrogen.
That's not a complete statement. You get this, but you did not put it. What does that 8 represent? Oh yes.
It means that H2SO4 has 2 replaceable.
Please clap for It means that H2SO4 has 2 hydrogen ion replaceable. Now the number of replaceable hydrogen ion in a molecule of H2SO4 is 2. Now, how do we prepare acid? How do we prepare acid? How do we prepare acid? So let us look at the preparation of acid. preparation of acid. Number one, we can prepare acid from acid anhydride. We can get acid prepared from acid anhydride. What do you call acid anhydride? Acid anhydride are the oxide of non-metal that dissolve in water to produce acid. You know, we want to prepare acid. You say one of the methods of preparation of acid is from acid anhydride. And I said acid anhydrides are oxide of non-metals that dissolve in water to produce acid. That means when you dissolve acid anhydride in water, what you get is what? Let us look at such. CO2 is an example of acid anhydride. And when acid anhydride CO2 dissolve in water, what we have is H2CO3. So H2CO3 is an acid. And how do you get H2CO3 prepared? We dissolve the CO2 in water. Are we together? Another example, SO3 is also another example of acid anhydride. And when SO3 dissolves in water, what it produces what? H2SO4. It means that SO3 is acid anhydride of what? H2SO4. We have NO2 react with H2O to give HNO2 plus HNO3. Now look at it. This is also anhydride, but we refer to this as a mixed anhydride. Look at the first two examples of anhydride I gave. Each one of them produces one acid. But getting to nitrogen 4 oxide, it produces two acids, dioxynitrate 3 acid and the triosonitrate 5 acid. Because this anhydride produces two acids, we refer to this one as mixed anhydride. The thing is that one of the methods of preparation of acid is by dissolving acid anhydride in water. And you have seen an example of such acid that can be prepared by the acid, from the acid anhydride. You've seen an example of H2SO3, you've seen an example of H2SO4, you've seen an example of HNO2 and HNO3. That is one method. Let's look at another method. Number two, direct combination of constituent elements. So we can as well prepare acid by combining the elements that are involved together. What are we called combination reaction? When two or more elements combine. Now let's look at example. I want to prepare hydrochloric acid now. Hydrochloric acid. The first thing I will do is that to get hydrogen chloride. By the time the hydrogen chloride is now bubbled through water, I have what? I have hydrochloric acid. Now this is what I'm talking about. Hydrogen gas can combine with chlorine gas. And when the two gases are combined, what you get is hydrogen chloride gas. You know, hydrogen chloride gas is a very soluble gas. When this HCl gas dissolves in water, what we have is hydrochloric acid. And that is, look at this, HCl, this is hydrogen chloride. By the time you dissolve it in water, because the gas is very soluble in water, we have HCl aqueous. This is now hydrochloric acid. This is hydrogen chloride gas. Is that again? So if I want to produce hydrobromic acid, we have hydrobromic acid. That means you are going to combine hydrogen gas and what? So that you have hydrogen gas combined with bromine gas. So this will give us hydrobromic. So, and by the time you bubble this one into water, what you have is what? Hydrobromic acid. That's another one. So we can as well produce acid by direct combination of the constituent element. Making how many methods now? The first one, from acid anhydride, you need to know what acid anhydride is. And the acid like H2CO3 can be prepared by dissolving the CO2 in water. H2SO4 can be prepared by dissolving SO3 in water. HNO3 can be prepared by dissolving NO2 in water. That is one method. The second method is a direct combination of constituent elements. I've seen an example of hydrogen gas and hydrochloric gas there. The number 3. Using a strong acid to produce less strong acid. Example, we can eat the mixture of sodium chloride and tetraoxosulfuric acid. When sodium chloride and H2SO4 is heated, we are going to have Na2SO4 plus HCl. This is an acid that we produce. So we are using an acid to produce an acid. Are we together? So this means we can use a strong acid to produce a less strong acid. Or strong acid to produce what? A strong acid. Or we can use potassium chloride, H2SO4. So there we are going to have K2SO4 plus HCl. So that is, so we also use this H2SO4 to produce this. So these are the 3 major methods by which we can prepare the acid. Using acid to produce an acid, using acid anhydride to produce an acid, and by direct combination of the constituent elements. Now, what are the physical properties of an acid? What are the physical properties of acid? So let's look at the properties of acid. Properties of acid. Can anybody mention the physical properties? Yes. Physical properties. Yes. You see, when you talk of physical property, litmus test is not classified as a physical property. It is classified as a chemical property. Is that okay? Don't write litmus test as a physical property. So we say, when I introduced or we started the class, I asked you when you drink unripe fruit, how will you feel? It is sour. And I say what is present in that acid is what? And that fruit is what? It is acid. That means one of the physical properties of an acid is that it has a sour taste. So number one, it has a sour taste. It has a sour taste. Concentrated acid is corrosive. Concentrated acid is what? Corrosive. And what do you mean by that statement? Why is concentrated acid corrosive? If you have an opportunity or opportunity for maybe an acid splashes on your skin, acid is a dehydrating agent. What happens is that you know about 70% of the blood is what? Is water. So when it gets to your skin, what it does is it takes up the water there. That means all the parts where the thing splashes, the water will be dried up. And what happens to the skin? It gets burnt. And that is how to explain the corrosiveness of an acid. So H2SO4 has affinity for water. So when it splashes into your body, the water present in the body will be what? Retain up. And when there is no water in the body, what happens? It will get burnt. To buy it, that's a snara. No matter how much you do, you torí pé acid yẹn ti dry omi tó wà nínú body, and that explains the corrosiveness action of an acid. So concentrated acid is corrosive. Not dilute. If it is diluted, you know the water that it affinity for has been added to it. So there is no way to take the water from the body again. Hence, what I gave you for the practical is a dilute acid. Even when it splashes, it will not wound you because it's already diluted. Is that okay? Now let's move on to chemical properties. NaCl plus H2O. This is an acid. This is a base. What type of reaction is this? What name is given to this reaction? Neutralization. An acid reacts with base to form salt and water. That is number 2. This is the basis of all the reactions that we are talking about. And you must know the characteristics of the acid so that it will help us in our subsequent topic. 3. An acid reacts with active metals, not all metals. An acid reacts with what? Active metals or reactive metals to liberate hydrogen gas. Remember, not all metals. So let us look at, we have HCl reacts with zinc to give zinc chloride, and there will be liberation of hydrogen gas. So an acid reacts with active metals to liberate hydrogen. Look at this. Can this reaction, can HCl react with copper? See, this reaction will occur. That's why you have to make use of what? Active metal, because copper is less reactive. It cannot displace hydrogen. So don't just say an acid reacts with metal to liberate hydrogen. Not all metals will react with acid to liberate hydrogen. So number 4. An acid reacts with triisocarbonate 4. An acid reacts with triisocarbonate 4 to liberate carbon 4 oxide. An acid reacts with triisocarbonate 4 to liberate carbon 4 oxide. This reaction is also very important. I want to test for carbonate salt. I will use for acid. Then once you add the acid to the carbonate salt, there will be effervescence. Effervescence means production of gas. And you can always tell for the gas produced. How do you test for carbon 4 oxide? You bubble the gas through light water. If it turns milky, you can say the gas is The gas is carbon dioxide. So we have, let us do another acid now. H2SO4 reacts with calcium trioxocarbonate 4. This will give us calcium tetrasulfate plus water, then plus carbon 4 oxide. So carbon 4 oxide is liberated when an acid reacts with what? Yeah. It shows that the thing, like you can see when the arrow I wrote here shows that the gas is involved. Just in that is involved. Or you don't need to write it there. It is not necessary. I wrote the arrow beside the gas showing that the gas is involved when doing that reaction. Is that okay? Yes. It has large amounts of water and a few amount of acid. But when an acid partially ionizes in water, it is what? A weak acid. Now what is acid anhydride of H2SO3? SO2. That is when SO2 dissolves in water, you produce H2SO3. Are we together? So what is acid anhydride of HNO3? NO2. You know when NO2 dissolves in water, it produces two acids. And one of them is triazonitrate 5 acid. What's the other acid that we produce alongside? HNO2. Now what's acid anhydride of H3PO4? P2O5. Can you use P2O5 or P4O10? Either of the two, when dissolved in water, will give us, that is a tetrahydrophosphate 5 acid. Then what is acid anhydride of H2CO3? CO2. Now CO2. And what is acid anhydride of H2SO4? SO3. Yes? Any question on it? Feel free to ask a question. If there is any. If you understand how do you understand how we arrive at all other one?
Yes.
Now, once dissolve this one in water, what will you have? That's reaction between the water and the phosphorus trioxide. Then you get your H3PO4. Write the equation. What you have to do with the equation now? I've told you what acid anhydride is. Acid anhydride is oxide of non-metal that dissolve in water to produce acid. I gave an example of this one. All you need to do when SO2 dissolve in water, what you have is what? H2SO3. You give an example of CO2, then that is plus H2O. This will give us H2CO3. All you need to do for that tetrahydride is just for you to dissolve, react P2O5 plus H2O, and you see that you've gotten it. Most of you don't try it, you don't get it. So, till I come your way again, enjoy the rest of the day. Bye. It's always happy. Yes, sir.